Hi everyone, so this is the question. So the first step we are going to do is we are going to mark the datum of the object. Next, we are going to divide the object into 3 sections, which is section 1, 2, and section 3. Next, we are going to include everything in one table, so it will be more neat and easy for us to find the answers. So the first step is we are going to find the area for every section. Next, we are going to find X bar. Next is we are going to find AX bar, which is area times by X bar. And then we are going to find Y bar, but this one is from the Y axis. It also be needed to be add with the length of the object to the datum. And for the last column is a Y bar, which is area times by Y bar. Last but not least, you have to total up everything and fill in the table. Next is we are going to calculate X bar and Y bar. So these are the formulas. We just need to include the value from the previous table. After that, we are going to calculate the IXX. So the formula for IXX is BD cubed divided by 12. So next is for the area. We don't have to calculate it because we already did it in the previous table. Next is R. The formula for R is Y minus Y bar. We already calculate the Y bar, so we just have to minus it with Y. Next is R square, and then AR square, which is area times by R square. For the last column is IXX plus AR square, as well as the section 2 and 3, and then we have to write the total of the IXX plus AR square. Next is we are going to calculate the IYY. The formula for IYY is DB cubed divided by 12. And same goes to IYY for the area. Next is R. For this IYY, we are going to minus X and X bar. And then R square, AR square, and lastly IYY plus AR square. So next is we are going to find the reactions for this beam. So this beam has two support, which is pin and roller support. So total is 3 reaction. So the first thing we are going to do is to find Fx, the second thing is Fy, and the third is the moment. So first step is to find fx. Fx equal to 0 is the same as hash a equal to 0. The second one is total of fy equal to 0. So the first is RA. The RA is going upwards, so it is positive, and the 20 kilonewton per meter is negative because it is going downwards. It has to be multiplied with add because it is a UDL, and then minus by 5 since it's going downward, and plus by RB equal to 0. And calculate everything and mark it as equation 1. Next, we are going to find the moment. We are going to use MA equal to 0. So the first is negative 20 times add and times by the arm from the MA. Next is minus by 5 kilonewton times by 5, the distance from the reaction to the moment. Next, okay, we already find RB, so we just need to substitute RB into the equation 1. After that, we are going to do the shear force diagram. So the value of RA is positive, so we are going to go upwards and mark the value. And the next is we are going to divide 20 into 2 distance, which is 20 times 5 and 20 times 3. So the first is 20 times 5 equal to 100. We are going to minus it, so it will be negative 18.125. So just take the ruler and line it up and mark the value. Next is 5 kilonewton. We are going to minus since it is not UDL. So minus by 5 equal to negative 23.125 and mark it as well. And then next, we are going to find the other distance of the UDL, which is 20 times 3 equals to 60. So just have to minus with 60 equals to negative 83.125 and mark it as well. So last but not least is RB is positive, so we have to plus with the previous value and to get 0. Okay, next is bending moment diagram. We have to calculate the area of the shear force diagram. To make it easier, you can mark it as section 1, section 2, and section 3. After all the values are ready, you can mark it at your bending moment diagram. So this is the first one. Don't forget to make a curve. If you make a straight line, it will be wrong. Minus with the second area because it is negative, so equal to 159.375. and then minus with the last area, which is 159.375, and it will be 0. So next is we are going to calculate y for this diagram. Lastly, we are going to find the bending stress of compression and tension to mark it at the bending stress distribution diagram. So these are the formulas for the two bending stress. The difference between these two formula is the y. Lastly is to sketch the bending stress distribution diagram. We have to draw the arrow to signify it is a bending stress distribution diagram. And also make sure the arrow is in the correct way. So next is to write the value of the bending stress, which is bending stress of compression and tensile. That's all. Thank you for watching.